Now that we've had a chance to get good at solving different kinds of systems with substitution, let's apply it to a real-life model. Here we have a word problem. Hannah has $11.20 in a jar that contains only nickels and dimes. There are 140 coins in the jar. How many of each coin does Hannah have? So I've broken this down here to kind of give you a template of what to do and when. Our first step is to identify what do we want our X statements to be. We're going to call those let statements. Well, we have two things happening in this system here. We have nickels and we have dimes. Now your let statements are always going to come from what you are trying to find. It wants to know how many of each coin does Hannah have. So that means that X will be one of the coins and Y will be the other coin. It does not matter which one you use. So I'm going to say that X is the number of dimes and Y will be the number of nickels. Okay, so our let statements come from our question. It said how many? Well, X is the number of dimes because that will tell me how many there are. Now it's time for us to actually write a system. Well, looking back at the first couple of sentences, I have been given information about how much total money there are in the jars and how many total coins there are in the jars. That means that I'm going to write one equation that talks about how much money there is, and I'm going to write one equation that talks about how many coins there are. So let's start with the money equation first. She has $11.20 in a jar. So that means that I have an equation that equals $11.20. And the left side of the equation, we have to put a little thought into it because it didn't come right out and say it, but we know that dimes are worth 10 cents. Now we can't just write 10, we have to make it 10 cents. So it's 0.10 times the number of dimes would tell us how much money in dimes we have. And if we add to that the 5 cents that a nickel is, times the number of nickels that we have, we would get the total amount of money in the jar. The other equation has to do with how many total coins there are in the jar. It said that there are 140 coins. So we know that if I take the number of dimes and I add it to the number of nickels, I should get 140 coins. Once you have your system set up, it's going to be exactly like level 2, level 1, and level 3. We're going to solve for a single variable. Well, that means that we have to ask ourselves, is there already a variable that's by itself? And there isn't. So we need to look to see, is there one that's easier to get by itself, meaning it doesn't have a number already written in front of it? And there is. When we look at the 4 variables, both X and Y would be easy to get by themselves because 1 is in front of them. So I'm going to choose to get X by itself. You should still get a same final answer if you had chosen to get Y by itself. But to get X by itself, I must subtract Y from both sides, leaving X by itself, and it equals negative Y plus 140. So we will take that expression of negative Y plus 140 and we will plug it in to our purple equation, which is 0.10 x plus 0.05 y equals $11.20. We're going to take and plug this in for x. So 0.10 times negative y plus 140 plus 0.05 y equals $11.20. Now it's time to distribute. 0.10 times negative y and 0.10 times 140. So 0.10 times negative y just gives us negative 0.10 y. And 0.10 times 140 gives us 14. Time to combine some like terms. We have negative 0.1 plus our 0.05. And you can just type those directly into your calculator. And we get negative 0.05 y plus 14 equals our $11.20. We'll subtract 14 from both sides. So $11.20 minus 14 gives us negative $2.80. And it equals negative 0.05 y. Now it's time to divide. So negative 2.8 divided by negative 0.05 gives me a positive 56. That means we're not writing our equation or our solution as a point because this is a real life scenario. We need to write what does that mean. Well, y indicates the number of nickels. So if y equals 56, that means we can already write into our solution that there are 56 nickels. And we need to figure out how many dimes are there. Remember, we take the 56 and we plug it into one of the original equations up here. I'm going to use the blue equation. So x plus y equals 140. And we're going to take and plug in 56 for y. Subtract 56 from both sides, and we get that x is equal to 84. That means if x is the number of dimes, that there are 84 dimes. Let's do one more word problem together. A total of 243 children and adults are at a movie theater. There are 109 more adults than children in the theater. How many adults are there? How many children are there? So let's go back to our let statements. Our let statements come from the questions. How many adults are there? Okay, x can be the number of adults. how many children are there? All right, y is going to be the number of children. So when I go to write my equations, let's look at what other information we've been given. We've been given a total amount of adults and children. So I can write an equation from that. The number of adults plus the number of children, it told me was 243. Then it told me some more information. There are 109 more adults than children. So that means that I need to take the number of adults that means I need to take it told me that there are 109 more adults than children. That means I need to take the number of children, which is y, and add 109 to find out how many adults. Is there already an equation that has a variable by itself? And there is. It's right here. So I don't need to do anything in this box. I can just start substituting and solving. So these are my two equations. And since x is already by itself here, I'm going to take y plus 109, our expression, and I'm going to plug it in for x. So I get y plus 109 plus y equals 243. 109 plus 2y, because y plus y equals 2y, equals 243. Subtract 109 from both sides, and we get that 2y equals 134. Divide by 2, and y is equal to 67. That means if y is the number of children, that there are 67 children. We still need to find the number of adults. We're going to take our 67 and we're going to plug it in to an original problem. So I can take 67 and I can plug it in for y in the second problem. 67 plus 109 equals x. 67 plus 109 is 176. So if x is the number of adults, then that means that there are 176 adults. Now we can always go back to the original problem and see if our numbers make sense. Well, it said that the total number of adults and children was 243. If I add these two together, then I get 243. It said that there are 109 more adults than children. If I take 67 and add 109, I get the number of adults, 176. So our equations worked out for us. They made everything true in the problem.